Hi, okay, so we are continuing with the second chapter capacitors and dielectrics. So before we start, basically this chapter is a short chapter and the marks allocated for PSPM is only 7 mark. Alright, so before we go deep, okay, I'll introduce what capacitors are and what dielectrics are. So basically, capacitor is a device that is capable of storing charges. I'm sure many have heard about the word capacitors and what they are used for commonly. And then we also have dielectric, where dielectric is a component that we can use inside a capacitor that can help increase the value of the capacitance without changing the size of the capacitors. So here I have a few examples of the shape of capacitors. Right, so this chapter has 3 subtopics. Let's proceed with the first subtopic. Subtopic 2.1, capacitance and capacitors in series and parallel. As always, when we have a quantity, it is very crucial for us to understand what is the meaning of the quantity. So the quantity that we are talking about is capacitance, denoted as capital C. So basically, every capacitor has its own capacitance. So ayat mudahnya kapasitor ni adalah nilai bagi setiap kapasitor. So, a capacitor having a capacitance is defined as the ratio of the magnitude of the charge on either plate to the potential difference between them. So, mathematically, we have equation number 10 where capacitance C is equivalent to charge Q over the potential difference across the two parallel plates, delta V. Okay, so usually the unit for capacitance can be derived from the equation itself where we have coulomb per volt, CV negative 1. However, farad capital F is the most common unit used for capacitance. Right, so obviously in many electrical devices, we use more than one capacitors inside the component circuit. So capacitors can be arranged either in series or parallel. So let's look what happened if we have capacitors arranged in series. So hereby I have a circuit shown 3 capacitors that are connected in series. By the way, series bermaksud sambungan komponen sebelah menyebelah. Okay, so if the connections of the capacitors are in series, that means all the charges accumulated between all capacitors are equal. That is, Q total coming from the battery potential difference will be the equal charge stored in capacitor 1, Q1, will also be equivalent to charge in capacitor 2, Q2, and also charge in capacitor 3, Q3. As in, all charges in the capacitor will be equal. However, in terms of the potential difference across each capacitor, so V1 means voltage across capacitor 1, V2 is the voltage against capacitor 2, and V3 is voltage across capacitor 3. So for voltage, okay, in series combination, the total voltage V here is the addition of all the voltages across each capacitor, as in V1 plus V2 plus V3. Therefore, when we have more than one capacitors that are arranged in series, we can find what is the total capacitance in the circuit, which is given from the equation 11, okay, where we have total capacitance for series circuit, or we call it capacitance effective, EFF, or we can also use the word equivalent. Okay, so for series, we have 1 over the C effective is equivalent to 1 over C1 plus 1 over C2 plus 1 over C3 and so on. Okay, or you can also rewrite that equation number 11 to get the C effective directly. Okay, which is 1 over C1 plus 1 over C2 plus 1 over C3 so on, and we reverse the answer. Okay, because here what we have is 1 over CF, not the C effective, not not the C total directly, but 1 over C total. So to get C total, you have to reverse the addition of 1 over all capacitors. Okay, alright, so that was capacitors arranged in series. And aside from series, capacitors can also be arranged in parallel arrangement. Okay, so unlike series yang disambungkan sebelah menyebelah, kalau parallel pula disambung bertingkat. Okay, so what changes if in parallel? Now the voltages pula yang equal. When I said voltage, I meant potential difference. Okay, so for parallel combination circuit, voltage yang equal, so V1 is equals to V2 is equals to V3. Okay, itu maksud dia. Because potential difference atau voltage ni dia read between 2 points. So sebab tu dia equal dalam parallel combination. And then yang berubah pula adalah charge. Kalau series tadi Q dia adalah sama, but for charge Q in parallel is the total addition of each individual charges in each capacitor. Okay, so because of these two concepts between voltage and charge, to calculate the total capacitance untuk parallel combination C effective, kita ada equation nombor 12, iaitu kita tambah biasa C1 tambah C2 tambah C3 dan seterusnya. Okay, so ini sangat penting. Right? How to find the total capacitance for capacitors is very crucial part in this chapter, where you need to understand how the capacitors are being arranged. Okay, kita ada dua jenis arrangement, series atau parallel. So sangat penting untuk kita faham bagaimana kapasitor kita disusun. Okay, adakah secara siri atau secara parallel, dan daripada situ menggunakan konsep yang betul, iaitu hasil tambah secara parallel atau hasil tambah secara series. Then only kita boleh calculate berapa total capacitance di dalam circuit tu. Okay, kenapa pentingnya we need to know the total capacitance? Alright, because we usually will be provided with the amount of the battery. Okay, bateri yang disambungkan pada circuit. So maksudnya kita tahu nilai bateri. So nilai bateri ni biasanya adalah nilai total lah. Okay, voltage yang datang daripada bateri, yang disupply daripada bateri merupakan total voltage. So bila kita ada total voltage, kita kenalah ada total capacitance. Okay, dari situlah kita boleh tahu berapa total charge yang disimpan di dalam circuit. Kenapa? Sebab we have Q charge is equals to capacitance darab dengan potential difference. So if the voltage yang kita ada, potential difference yang kita ada ni adalah total, maksudnya C tu kena total jugalah. Barulah kita dapat Q total. So if I have voltage in capacitor 1, that means capacitance here must be capacitance capacitor 1. So charge dia pun adalah charge yang pertama. Dia macam tu. Okay, kena ingat. Alright, next kita tengok. So since capacitor is able to store charge. So bila kita kata dia store charge, maksudnya dia simpan energy. Okay, dia simpan energi dalam electric field dia. Okay, maksudnya sekarang ni capacitor kita ni adalah 2 parallel plates. Okay, remember kita belajar subtopik 1.4. Bila kita ada 2 parallel plates, maksudnya kita ada positive plate and negative plate. So daripada positive dan negative tu, dia akan create satu electric field. Direction positive to negative, and the electric field tu is uniform. Okay, so yang warna merah ni adalah electric field yang uniform. So dia cara dia menyimpan charge tu adalah cara dia menyimpan energy tu adalah through dia punya electric field. Okay, so we do not know how it looks lah, kan? Obviously we could not see all these tiny particles, but that is how the energy is being stored, okay, dalam electric field dia. Okay, so to calculate the amount of energy stored U, capital U in a capacitor, okay, we have this equation number 13 here, where U, okay, is equals to half Q squared over C, or we can also use U equals to half CV squared, or lastly we have the third equation for U, which is half QV. Okay, so kat sini tiga-tiga equation ni adalah equation yang sama, iaitu mencari energy stored. Okay, so bila energy stored ni, okay, nak guna Q, nak guna C tu sangat penting. Okay, if you have the total voltage here, that means you need to have total C atau total Q. Dia tak boleh guna nilai bateri, tiba-tiba guna nilai Q dekat kapasitor 2. Yang mana Q kapasitor 2 tu tak sama dengan Q total. So tu tak boleh lah. Okay, so nak guna any equations for you ni, you have to alert with the values that you have. Okay, tak boleh sewenang-wenangnya mengganti. Kalau ada nilai C total, nak guna equation yang tengah ni, half CV squared, C total, V mesti total. Tapi kalau V tak ada total, tak bolehlah nak guna formula ni. Kena guna formula yang U equals to half Q squared over C. So C total, Q total. Okay, so I'm sure you know what I mean. Alright, okay, so let's try to do exercises question. Okay, boleh tengok soalan exercise from your buku tutorial and solve the problem. And then understand atau soalan pasir pun ada juga. Okay, so pentingnya kat sini kita kena tahu apa charge voltage ataupun capacitance yang kita nak gunakan. Alright.